Good afternoon. My name is Lance Campo with the marketing department here at Clean Air Industries. Welcome to our webinar, The Hidden Hazard, How to Tackle Oil Mist and Smoke for a Safer Workplace. I'll be hosting today's event, and I'd like to take a moment to thank each of our guests for attending the presentation. So, oil mist and oil smoke are a common workshop pollutant that are usually generated from machining processes like milling, lathing, or drilling. Simply put, it's messy and it compromises the health and safety of workers. So today we're going to take a closer look at this specific problem. Our presenter today is Mark Eccles, Head of Industrial Sales at Clean Air Industries. Mark has years of experience in this topic and can offer a lot of knowledge on how to effectively manage this hazard in a variety of manufacturing environments. I've seen this presentation a couple of times, and I'm always learning new information. So it's my hope that it'll be as helpful to you as I find it.
All right. Thank you, Lance. I appreciate the introduction, and thank you all for joining the meeting today. So, like Lance said, I hope you guys get a little bit out of this. I've been doing this for several years and have a decent amount of knowledge around this. You're always learning stuff. Every time you walk into a new plant, there's always a different challenge, and there's no one right way to do it and no one wrong way to do it. But anyway, just to start off, I wanted to talk to you guys about the oil mist and oil smoke filtration and where it comes from, and that is mostly machining processes. These new high spindle speed machines now, they can really produce some very small air particulate that is very harmful to your lungs. So you can kind of see in the diagram over there, these oil mists, they'll actually create mist that is 5 microns and up and all the way down to less than 1 micron. And obviously, the less than 1 micron is what the very harmful effects to your alveoli and your lungs. They actually can get into your bloodstream from your alveoli in your lungs. So, and that's really what we want to key in on, is the health and safety portion of this. So a little bit more in depth about the health and safety standards is pretty interesting. And today I'm actually at a show in Greenville, at South Tech show, and I was actually talking to a couple of guys, and they asked me what the OSHA standard was. So and they wanted to know what it was in Japan as well. And so I actually I didn't know what it was. I actually looked it up today, and it was pretty interesting. So in the US, the OSHA standard is 5 milligrams per cubic meter. That's your exposure limit. And in Europe, it is 0.5. And I'm here to tell you, I have seen a lot of factories in the States that is, they actually are meeting the standard in OSHA. And it is still a fairly foggy, dirty, slippery place. The standards in the US are really low. In converse, the European standards is a 0.5 milligrams per cubic meter. And you walk into a place that are meeting those standards, and it is a very clean, bright, smog-free. You can walk around without worrying about falling down. It's very nice. And the Japanese are at 3 milligrams per cubic meter. So kind of in between there, still on the high side. But so what happens is the coolants and the mist will escape the machining processes, and it just gets all over the floors, all over the ceilings. And besides the health hazards it causes, it can cause unsafe conditions in the plant as well. So oil mist actually comes from water-based coolants, and your oil smoke comes from straight cutting oil. And most of the processes that I've seen out there are mostly oil mist, which is your water-based, and they're from grinding, turning, milling, and machining. And so those are a little bit of a lighter mist, still just as dangerous as oil smoke, but the oil smoke is a little harder and a little it's a little got a lot more concentration. So it takes twice the filters to handle an oil smoke application as it does an oil mist. And a lot of that you're going to see coming from some like cold heading and heat treating, some of your forging, and even some tube mills. Most tube mills are oil mist, but some of them can be a smoke. As I said, we offer 9 different collectors out there, and within those 9 collectors, you can actually gang some of them together to get twice the CFM. But what makes the technology that we use so good is it's a coalescing fiber bed technology. And you can kind of see down on the lower diagram, that's a microscopic camera little video that we did of how our media coalesces the mist when it gets introduced into the filter. So what it does is it coalesces, and that globule will grow, and it'll eventually drop out of the bottom of the collector into a catch pan, and then that catch pan drains off and down to your sump or to a filter, or however you want to handle the leftover fluid. You can reclaim the coolants or the oils once it goes through a filter. But the biggest thing that I try to instill in my potential or current customers is the minimal maintenance that has to be done with these collectors. We guarantee 1 year of filter life in our collectors. And what I see mostly out in the field is it's going to be more like 2 to 3 years. Yes, the filters are fairly expensive, but compared to some of the other older technology that's out there, it is the payback is very, very short, because you're not maintaining these machines every single month like you do in a lot of the other ones. And then the last thing that makes our systems pretty unique is it is a centralized platform. So you can have one collector hitting 9 or 10 machining centers all at one time. So, but we'll get in a little bit more on the filter and how it works in just a minute. But so I mentioned some of the competition out there, and the mechanical, electrostatic, and centrifugal filtration systems, they've literally been around since the 70s. And the mechanical is just like a bag filter collector, very, very short filter life. Most guys, they forget about it, and then all of a sudden they see a bunch of smoke in the plant, and the reason is because the filter is completely clogged within a month or two. Electrostatic filtration actually works extremely well. It's very, very efficient. But the plates that collect the mist has to be cleaned off at least once a month. And if you don't, then it's all hitting the HEPA after, and then your HEPA after fills up fairly quickly, and then it's another, it's a $500 filter that you got to change out. So, and then the centrifugal, which is you'll see that a lot on OEM machines. They come with them. They work really well on the large particulate, the 5 and larger. But it just lets the really small stuff straight through it, though. It doesn't filtrate that out. Again, you can stop that with a HEPA filter, but again, you are going to be replacing that HEPA filter every single month, and if not, it just doesn't work. So that's where the maintenance is a real cost out there, and it's like I said, the payback time on our collectors is usually less than a year. Even though they're a little bit more expensive upfront capital cost, it will save you a lot of money on the long run. So a little bit about how our collectors work. This is kind of a drawing cutout, so you can kind of see on the left side where the dirty air is coming in to the collector. You have stage 1 that takes anything from 1 and up microns and will filter all that out. It'll coalesce, drop down in the bottom, and you can kind of see the little drain that goes down into a box. So we also offer a pump if you want to pump your your leftover liquid somewhere or coolant somewhere else to have to use later or just to throw away. But anything that gets through filter one, the first stage, stage two will filtrate anything from 1 micron down to about 99%, 99.7%, which is pretty much gets everything. If there is anything that does get through, then we do have a HEPA sitting on the top, and that is a 99.997% efficient filter. So basically, the air that is coming out of our collectors is cleaner than the air that you're going to be breathing if you just walk outside. So very, very efficient. And like I said, the filters you pretty much can count on, unless it's some unusually heavy concentration of mist, you can count on them 2 to 3 years. I have seen some at 6 and 7, but however, they were pretty light applications. But and then there's one other option that we also do. So if you've ever seen like a tube mill that it'll bends a piece of metal up, welds it, and then directly dunks it into a oil bath or some kind of cooling system. So you're getting oil mist and weld smoke all at the same time. We have a spray system that we can put in that sprays water on the bottom of that first filter, and it keeps that filter moist. The last thing you want to do in these type of collectors is have any kind of drying out of that filter. It'll block them pretty quickly if you dry them out. So they can so if you're doing like wire drawing or some kind of a dry-ish type application, then we recommend do the spray system under there, and they work really, really well in those situations. And then we do also have pre-filters in these that just keeps the scarf, tries to keep a lot of the bigger scarf out of the filters. So that's basically how our collector system works. It's fairly simple. When we come out, there's specific things that we look for in your application on how we select the correct collector for your application. And what we do is we bring some people call it a sniffer, but it basically it tests the sample of the air, and it allows us to see how much concentration is coming out of either the outlet or in the operator position. I usually take readings in the aisleways, and it gives me a good idea of where the problem areas in the plant are. Number one, number two, I usually if there's a slinger on there, I will literally put the tube in the outlet there and measure what the concentration is coming right out of that machine. And so anything that's from 2 to 27 milligrams per cubic meter is pretty much going to be a zero mist unit. If it gets over 27 and up to around 50 milligrams, then I will probably use one of our oil-based, zero smoke units. And if it pegs out over 50 milligrams, then it's always going to be our high smoke unit, which is one of our workhorses out there. That's where your tube mills, forging, heat treating, coal heading, those are really, really higher concentration type applications. And the last thing you want to do is put the wrong get the wrong collector on the wrong application. So it's pretty important that we have these readings and we know what those concentration levels are that are being emitted. So that's just a pretty simple synopsis. And if you have a customer that you want me to come out and see, it's a fairly simple way of telling and on which filter we need to use. And then as far as the CFM, the way our collectors are numbered, you can see like the OM 600 to 3600. Well, that actually means CFM. So each one of these filters can take around 1200 CFM on a smoke application, and about 1800 CFM on a mist application, and 1800 CFM on a smoke. We do make some little smaller units called an OMC, and they are half filters. So we can do around 600 CFM on those. So again, it just really, really depends on your typical application that you have going. So the way, these are mostly are not, machine mounted collectors. These are more centralized collectors, as I mentioned in the past, and just a little while ago. So you can kind of see some examples that we have here. The little video that you got way over there on the left, that is actually a tube mill. You can see two different streams of smoke coming up in there. The first one is the welding, and the second is the mist. And we have that on on the one that on the collector that you see right next to it, and that is our high smoke 2400. That thing's around, it's about the size of a pallet, and it's about 16 foot tall. But that is our workhorse. That's when you have the really nasty applications like a tube mill that sits there and runs 12 hours a day, 6 days a week. I've got one of those not too far from our plant that have been really able to keep a good eye on, and we're over 2.5 years on the filter life so far, and they still don't need to change the filters. So they're a really they are our workhorse. You can kind of see in the third picture from the left over, that's a couple of 2400s that we ganged together. I think I've got in this particular application, I think I have like 10 machining centers on those two collectors, but you can see it where it gangs at the bottom. And typically, we just exhaust right back out in the plant. You can see in this picture, we're actually exhausting it outside. That is the customer spec. That's what they wanted, and so that's what we gave them. And then you can see on the far right there, those are big 3600s, and you can't tell, but those are two of them getting together, and you can see all the machining centers that those things are collecting mist from. So, we can go from one machine to 20. And so it doesn't matter, it's just CFM and know what your concentration level is. And we can come out and do this out survey for you, get a recommendation on what we think is the right way to do it. And then get you a quote. So just and a quick note on duct speed for any of you guys that are familiar with filtration, weld smoke, your duct speed is 2,700 to around 3,200 feet per minute. Your plasma and laser dust, you want to speed that up a little bit because it's kind of a bigger particulate. So we speed that up to around 3,500 feet a minute. It's what we try to target in the duct. And then more like your carbon black, your really big stuff, fiberglass that you want to make sure no fallout in that duct. You run that up to around 4,000 feet per minute. Well, in oil smoke, you're really between 22 and 2,500 feet per minute. And it's interesting, you always want to try to lean the duct back towards the machine. So once you turn the machine off, the fluid that's left in the ducting will drain back down into the machine and not into the collector. And that saves the customer money in the long run. And here's just a few of the layouts that we've done for some past customers. I just threw in here. Some we can get as complicated as you need. It's just ducting systems. We try to make sure we don't have any obstructions, so we don't have to go north or south with the duct. We want to try to keep it on a level playing field and lean it back towards the collector, like I said. This is actually, I think US Duct did this layout for me. I kind of drew it out for them, and then they do a 3D layout. Same type situation. This was a CAD drawing that I had, and that's a couple of, I believe that was two 3600s, and each 3600 is picking up 8 machining centers. So, it's the customer was very happy with this. It works extremely well. This is usually a little bit more CFM than we actually needed, but these machines had some pretty big cracks in them as far as spaces where mist was getting out. So I had to add a little bit more CFM to make sure we had that negative pressure on that cell or that machining center to keep the smoke inside when they open the door up. And that's kind of how we determine how much CFM that we're going to need. It's really very dependent upon the manufacturer of the machine. Some of them do a really good job of keeping it enclosed. Some of them they do not. Open lathes and things like that are extremely difficult applications to handle because there's just no way to source capture that mist. However, most of your machining centers is fairly easy to do. So, well, I blew
Okay.
through that pretty quick, didn't I, Lance?
You did. Yeah, I'll tell you something. My teams here kind of got messed up a little bit here, so we're gonna have to do our question and answer period on the fly. Let me.
Okay.
Okay, I'm gonna shut that off. I'm gonna stop sharing my screen. You mentioned coal heading, and I've heard this particular application mentioned a few times. I'm not 100% familiar with this. Could you just give me a preliminary again on what that means?
Well, coal heading it can be a lot of different things. A lot of them you're putting a head on a nail or something like that. But it uses a little bit, just a little bit of, and it's always straight cutting oil, and it produces a lot of smoke depending on what the application. Some of them don't. I've seen from a lot of smoke to just a very little, but it is oil smoke, not mist, and it's very concentrated, and you definitely have to use our smoke units on a cold heading application.
Okay, I do remember working on a drill when I was in the shop, my shop days, and that cutting fluid is really heavy duty,
Yeah.
difficult smoke, very, very nasty stuff. I got a question here from Nathan Ritchie. Is it acceptable for the leaning ductwork to connect directly to the unit using a 90-degree elbow?
Is it necessary?
Is it acceptable for
Oh,
the?
acceptable. Yes,
Yeah.
of course. Yeah. And there's a couple of different ways that I have seen some of our installers install the ducting onto the collector. They can use a little bit of a leaning plenum on it. I've seen them make some crazy triangle looking things, so it tries to drain everything into the collector. But at the end of the day, you there are some applications that you do not want to lean the ducting towards the application, but you do want to lean it towards the collector, and that would be like a wire drawing application where they don't want anything back into the cell. You want it all into the collector. So
Yeah, you don't. Yeah, you don't want the contaminant coming back.
correct.
Excuse me. Could you talk a bit about some of the what kind of cost savings could an operator expect? And what I mean by that is for coolant and fluids that are recaptured or reclaimed. Is there some kind of number or at least a percentage that you could estimate?
I don't know. I really don't know what the estimates on that type of thing is. Some emulsions cannot be recovered. Some can. It really is very dependent upon the coolant that they are using, and they will. Most of the machine guys will know if you can recover that or not. So that's a good question, but I don't. I really don't know the numbers on that.
Would you have to refilter the reclaimed materials, or
Yeah.
yeah,
Yeah,
and
you have scarf. You have a really small particulate that gets into the coolant, and it'll go right up with the mist. So you do have to filter that. Yes.
okay. And just again, if you'd like to ask a question, please submit your question by the question and answer function. We're here to help you guys understand these applications a bit better. And when it comes to oil, you mentioned emulsions, and that's the lion's share of what we would typically be using this equipment for is water-based emulsions versus oil, or is
No,
it a 50/50?
we have both. We can do both. I just see a lot more emulsion type water-based coolants than a straight oil.
Yeah. Okay. And when it comes to different materials like machining aluminum or copper or steel, is there some sort of variation in the smoke and mist that coming off, or does it depend on the turning speed of the equipment?
All of the above. All I
Okay.
care about, all I care about is what the concentration is coming out of that machine, and that's what I base my recommendation on which collector.
A moment ago, you mentioned large scale lathing. So if you were doing, let's say, a
Mm-hmm.
large spindle, 6 to 8, 10 feet wide kind of thing,
Mm-hmm.
and anyone who's been in a manufacturing facility where they have a giant lathe like that knows that everything, the smoke just goes everywhere. Is it possible to build some type of an enclosure that you could
Yep.
maybe have it over the space or even a retractable space?
Yep. That's what you would have to do, because most of the time on those very, very large lathes, you got a crane over them, and
Yeah.
you would need to fashion some kind of hood that you can close off that space above the lathe, around the edges. You want to contain that mist inside that space, and then you'd vent it from there. But yeah, you would need some kind of hood that would either flip up or slide back, or something along those lines. And we have done those, not necessarily on oil mist applications, but definitely on weld smoke applications. We've done several of those type of hoods, but it could definitely be done on that. We just have to take some more care to make sure we have everything closed off really good when we made that retractable type hood. So
When we've had some conversations in the past, Mark, about some of the equipment that's typically being used for these oil mist applications. You've mentioned slinger equipment and centrifugal type equipment. Could you sort of walk me through, because we've talked about this a bunch of times, and each time we discuss it, I'm reminded that while cost may be a factor, the quality level and the maintenance level is they're non-comparable. And I know you touched on that earlier on, but could you expand on that particularly a bit more?
sure. Yeah, both your electrostats and electrostatic collectors, and your centrifugal or slingers is kind of the industry slang for those. And they come in a lot of different sizes and specs, CFM, and all that. But the one common thing that they do have, especially in your centrifugal, is it is not efficient at all. It, like I said, it will let the small particulate, uh, you know, 3 microns and under. It doesn't do anything. They just go right out the exhaust. And the only way to contain that exhaust is putting an after filter on it. And obviously all that concentration is hitting those HEPA filters, where ours, to make we're catching most of the small stuff in our stage 1 and stage filters. So very, very, very little is ever even getting to our HEPAs, which is
That's
why those HEPAs will last 2 to 3 years without even swapping them out. When it's time to swap stage 1 and 2, we typically go ahead and swap the HEPAs at the same time.
Yeah,
So
and that's something that needs to be reiterated for people that are
yeah,
considering these different types of products as when it comes to maintenance and cost. That's the thing that really stuck out in my mind is when you talked
yeah,
about having a certain particulate load hitting that HEPA filter and having to change it out much more frequently. We all know how expensive HEPA filters
yeah.
are. They cost a
You,
fortune.
in some of these plants I've been in, there's 40 to 60 machining centers in a building, and you've got slingers on or electrostats on every one of these. There's somebody that's got to go around if they want to keep a clean plant and maintain these every single month. Well, that'll keep a maintenance guy that's a busy the whole time. He would finally get to the last one, and by the time he got there, he got to start
I was
back
gonna say
over.
that's a
So
full-time union scale guy doing that type of work, weekly, monthly would
yeah,
obviously add up very quickly.
very
Uh, when I think back to my earlier career, I worked in a factory that had a large machining shop. They had about 12 units in there, and they did not have any particularly effective oil mist collection. And there was slippery surfaces and tools all over that shop. Could you could you tell us a story about maybe a time that you went into a shop and you experienced something like that?
yes. I was actually in North Carolina. I will not say the customer, obviously, but they knew they had a problem, and they actually had some collection in there, and it was old bag filter style collectors. The ducting was leaking everywhere, and that is one other thing I forgot to mention on the ducting is you don't use a regular dust type uh, ducting, the clamp together or flange ducting. This is a pipe that we use, and it has got neoprene washers on there. It does clamp just like your clamp together ducting, but it is waterproof. So, but it has to be installed correctly. You can't have any angles on it or it will leak. But as long as it's installed correctly, it won't leak. But yeah, I was rounding a corner in this place. And like I said, the guy called me up there because he knew he had a problem and wanted me to just come in and see how much it would cost to fix this problem. So I was going around doing my readings with this guy, and believe it or not, as nasty as the place was, he was still under the 5 milligrams per cubic meter. So he wasn't in danger of, getting flagged by OSHA or anything like
Oh,
that.
jeez.
But I actually fell. I turned around, turned the corner, and had on boots and slipped down. And the guy it was bad. But anyway, so they
I
actually ended up doing nothing that I know of. But it is
I
what it is.
That's what I
So
asked because it stuck out in my mind the first day I walked in that shop, and I noticed how slippery everything was, and nobody seemed to think this was a problem. And me
yeah,
and my being a bit naive, I was like, why don't you guys just clean this up? Not
yeah.
understanding that there's a cost involved and specialized equipment. And can you talk a little bit more about some of the larger projects that you've seen? I know you had the Mando example there a moment ago. That
Hmm.
was two 3,600 units. Plus, you just showed a diagram that had 8 machine centers per, so that was
Yeah.
16. And typically, how many would you see if you
Yeah.
go into
What
a
you
standard shop?
Right. Well, for like the Mando down in Georgia, they're a supplier for Hyundai and Kia. They that is just one line. We've probably got, I don't know, 12 or 14 total collectors in that place, because my goodness, I think they have like 80 machines in there. So, and then they're churning it out, man. They run 24/7. So, but typically, I wouldn't even, there is no typical. I mean, you can get some shops that's got 2 machines in it because they just got a small thing going, and those are the ones that you're never going to put one of our mist collectors on. But the ones that you see 8 to 10, that's where, and they're in a smaller room or something like that. That's where you're really going to see the effects of a subpar, mist collection. But especially when you get into the larger, and there's a lot of them out there, larger machining businesses that do these parts. You may have 40 machines in there, and if they're not, if you have that subpar machine filtration on them, you will always see a haze you'll see a haze in the ceiling and a little guy riding the floor sweeper 24/7. I mean, they have to sweep the floor all the time for safety, or mop it. So
I could just imagine the guys on the forklift drifting across the facility, Tokyo
yeah,
drift style.
most of the facilities, they do a good job of keeping the floors dry, clean, washed and cleaned, so you don't have those slip. But my goodness, you're paying a couple of 2, 3 guys, to go through the plant. I mean, it's a 24/7, or they have a robotic type cleaner that goes around the floors. But
Yeah,
then
the ongoing cost.
anything you touch though is just oily and slick and nasty. You can't lay your notebook on anything.
Well, I think that's going to wrap it up for us, Mark. Again, like I said, this is probably the third time I've seen you do at least some of this presentation. Again, I've learned something new, as I always do. So I appreciate you taking the time to meet with our guests today to learn about it. We are doing a continuing series of webinars here at Clean Air Industries. Our next one should be in December, and I think that's to be determined at present. So I'd like to invite all of our guests to come back and join us for that. Thank you again, everybody, for joining us, and stay tuned for future broadcasts, and we'll see you then. Until then, have a good night. Thanks, Mark.
Thanks, guys.